Welcome to Stanford. Welcome to another edition of Open Garage Talk. This is one of our favorite events here on campus. I see some familiar faces in the crowd. I know that some of our friends are getting their 5th Open Garage stamp on the taco truck, which I like to see. This is an event that we throw really to put Stanford and our researchers and students and faculty together with our friends in the community, and it's been a real success over the last sort of 2 years we've been running these. It's great because we get to share ideas, you get to bring ideas to us, and we just simply love doing it. So my name is Riley Brennan. I'm the executive director of the Revs Program here at Stanford, which is one of the many programs and centers that use this facility here called the Automotive Innovation Facility. And tonight we have a really special event planned for you. We have essentially a celebration of the Stanford Solar Car Project, which some of you know because some of the people in this room have been really instrumental in bringing the team to life in the form of sponsors. For those of you who don't know about the project, it's a completely student-led race team. And student-led, student-designed, student-built. Students actually go out and fundraise, and it's a fantastic project that really is, I think for the students who have been a part of it, is one of the pivotal things they do here at Stanford, and certainly the alums of the program have gone on to do amazing things, not only in the automotive world, but throughout industry. With that, I want to welcome our first special guest for the evening, Guillermo Gomez. Guillermo is a second-year ME student who started with the team just a year ago and was a part of the test team for the car that ran last summer. And Guillermo's a really special guy. He's really young. He's really talented. He's been instrumental in putting this event together, but he's also the team lead for the car that's going to race next summer at the race that he'll tell you about. And it's great to see such young, great talent here within Stanford and on this team. This is kind of how the project lives on, is that the older team members pass it on to the younger team members, and Guillermo is sort of next in line. So with that, please welcome Guillermo Gomez.
Thank you, Riley, for that introduction. Welcome, everybody. My name is Guillermo Gomez. I'm a sophomore here at Stanford, majoring in mechanical engineering and minoring in political science, but that's aside from the engineering. So I'm really excited to be here today. We're here to celebrate our 25-year history at the Stanford Solar Car Project, and specifically to celebrate our results this past race cycle with our 2013 car, Luminos. Now, before I talk more about this really cool car, let me tell you some more about the project. The Stanford Solar Car Project was founded in 1989 here at Stanford by some really driven engineering students. And it's an entirely student-run group. What we do is we design, build, test, and then finally race solar-powered vehicles. So we compete every 2 years in something known as the World Solar Challenge. It's a really large event held in Australia, and we are required to drive 2,000 miles across the entire Australian Outback, just using solar power alone. It's a really competitive event, and it's called a challenge, not a race, because not everyone finishes. It's really difficult, and rising to that challenge is something that we're really excited about. So our work helps push the boundaries of ultra-efficient electric vehicle design. We have to think about a lot of different components and design considerations when we make this happen. And then we also have to test it and make sure everything works, make sure everything is safe. Because the car is an electric vehicle, we add another component to it and make it a solar electric vehicle. So having a car that runs on the sun is even more challenging than just having a car that runs, and that in itself is a challenge too. But this really provides a unique hands-on experience for everyone involved in the project, all the different students that get to work on this. And it's a really good way to supplement your education here at Stanford. In terms of engineering, there's so many challenges on the car, from electrical engineering to mechanical design to aerodynamic modeling to just testing different components. And if you're not an engineer, that's fine too. There's a lot of business and logistics planning and administration that has to go into the project. So anybody and everybody can get involved in that. We're an open student group. Now, our latest car, Luminos, which raced in the 2013 World Solar Challenge, this very grueling race. It did very well. Our primary goal in designing this car was to make a car that would not break down during the whole race. And it did that. It did not break down at all. We had no significant failures of any sort. So we achieved that goal. And in fact, we did it so well that after testing the car, putting several thousand miles on it, and then finally getting it to this race and completing the race, we placed 4th in the world, which makes us the best undergraduate solar car racing team in the world, and I guess the best American team too. But despite the lack of impromptu repairs, this past race was one of the most exciting in our recent history. They're not supposed to be exciting. That's when things go wrong. But we were just so close to placing even better. So it was a very contested race, and some weather conditions came into play, but we pulled through nonetheless. So now I would like to go ahead and introduce our next guests. We have a panel here of some of the solar car members that went to this race. I unfortunately was not in Australia because I was doing homework. But that's okay, I will go to Australia soon. So without further ado, I would like to introduce our panel. We've got Darren here, Jamie, Wesley, Max, Anna, and Professor Christopher Gerdes, who is our faculty advisor. Welcome them. Thank you.
Great. Well, it's my great honor to get to moderate this today and to be here with the team as they share some of the experiences and stories that they had in the Outback. So I want to start off with Wesley Ford. Wesley was the finance manager and business and logistics lead for the prior car Zenith, and he was the team director of Luminos. Wesley has graduated since then. He graduated last year with a degree in economics, is now a program manager at Google. So one of the things I wanted to ask you, Wesley, is this is a team that comes together and does amazing things. And in return for that, we basically give you all nothing. You know, in terms of academic credit or things like this. This is really a labor of love. How do you get a team organized to do that and to put in the sort of energy that you do?
Sure, it's definitely a big challenge. People on our team have a lot of things they have to balance, whether it's balancing classes in solar car, or balancing your club sports or your other sports in solar car. So one of the biggest things our team focuses on is trying to find a way to keep people involved, keep people motivated. Unlike the lion's share of companies here in the Silicon Valley, we can't motivate our engineers with pay bonuses or benefits or even equity in a startup potentially. So for us, we found a few things that worked surprisingly well for kind of balancing the needs between students working on a team and their other commitments during their time here at Stanford. One thing is having exciting test drives even. So for example, a lot of the folks that you see on this panel and the ones that have stayed on the team are ones that have had the chance to go on some particularly daunting or exciting test events throughout California and the US even. I know one of the most exciting drives we had was right at the start of this team cycle where we took our last car, Zenith, went out to the Central Valley in the farm country near Fresno and did a weekend of test drives. And there were, I guess, many perils in some sense. We always do about things like tire blowouts on our trailer and escort vehicles. Even camping the night in a trailer park out in the middle of Modesto or Fresno can lead to some interesting experiences. But for the folks that survived through that experience and put out the hours, the end of finals week, to go on a test drive, I think they really bond together as a team. And a lot of those folks that end up on those test drives make all their way through their 2 years or even more. Team members of the long haul team going out to Australia. Other things that have worked well that we found are really making sure that students on the team have strong mentors. So we make a big effort to ensure that students that are upperclassmen, students that are even alumni and are often professional jobs in the Bay Area still stay involved with the organization, whether it's mentoring an individual student or even just coming in for a design review every now and then. Having kind of the legacy of upperclassmen has really made a big difference on this team and keeping people engaged and excited about doing a lot of work on top of their classes to gain skills for engineering, and also business throughout the team.
So you worked to bring everybody together as a team. You, I know in this cycle, tried to do everything as early as possible, and yet, despite best efforts, occasionally there was a need for beast mode. Can you explain beast mode to us?
Sure. So beast mode on our team is when you've procrastinated a little bit too long, maybe, focused a little bit more on your classes or other commitments as opposed to solar car, and then finally realize you have a deadline that's in 24 hours. And so beast mode is when you're here at the shop and you're here until 8 a.m. in the morning trying to crank through your project all the way through the completion in one quick run. Early in our cycle, that was kind of the norm on this team. But we tried in this cycle to move away from that a little bit because we found a lot of the results that come out at 6 a.m. or 7 a.m., even though to you in your rage of Red Bull or Energy Rockstar or something like that seem amazing. When you wake up the next morning at 4 p.m. or whatever it happens to be, they may not be the greatest results. So this cycle we tried to be a bit more diligent in integrating things early and testing early. And this cycle we're happy in the fact that Luminos went out to Australia before the race with about 5,000 test miles, which was many times more test miles than we've ever put together in a previous car. So beast mode is hopefully part of the past, but it still creeps up every now and then.
Great. I want to turn to Darren Chen. Darren's a junior in mechanical engineering. He was on the mechanical team for Luminos and is currently the engineering director. Darren, one of the comments that you made to me which really stood out was that you go through this process of building a car, and then you get to Australia, and you suddenly have to transform from a design team to a race team. Can you explain what that means and how you did that?
Absolutely. So that is definitely one of the biggest transitions. Getting to Australia and then realizing that you become a race crew. So all of a sudden you have to, not only you've got to make this car that you've made somehow perform in the race. And Guillermo, if you're on the slide with the wheels, so one of the cool things about our car is we have what seems to be an easy on-off wheel swapping system. There's these pins that fit into the rotor on our car. But when you couple that with increasing aero performance, we ended up having a wheel cover over the car. So after designing and iterating on your car, you get better performance, but all of a sudden, these pins that you used to be able to see when you're putting on and taking off the wheel, you don't see them anymore. So you get to the middle of the Outback and you realize, well, these design adjustments that we've made they're really hard to make work in the Outback. So you've got all of a sudden you hit the Outback and you've got to do race crew training. So what we do is we'll all get in a big convoy and we'll practice driving along the road. And someone in the lead car, or the scout car, usually it was Wesley, would be like, all right, front right tire blowout, pull over immediately. And then you'd have cars all of a sudden pulling over the side of the road. You got to guard your solar car against other passing vehicles. And all of a sudden everyone's running out of their vehicles, in yellow safety vests. And you run over the car, people pick it up, you jack it up, and you got to somehow get on this new wheel or your blown out tire or practice, some mechanical failure. So doing that versus sitting in a chair is definitely a big jump. And by the end of these practice runs that we did in Australia, we were able to get this wheel change, which used to take like 15 minutes. I can't quite find the pin. Oh, Jamie, can you move your leg like just a little bit? I gotta wiggle this in there too. We were able to simulate a wheel blowout and change it, get back on the road in 3 minutes. So it's like a big step from drawing this part on your computer to actually having to service it on the road and be able to race your car like that.
So you did a lot of practice to prepare for that, but then there are still the unexpected things that come up. And right before the race, you got hit with a big one, didn't you?
Oh yeah, absolutely. So that was probably one of the darkest moments during our Australia trip. What happened was before the race, we were test driving for approximately 2 weeks. And about a week and a half before the start date of the race, we were doing a mechanical check. And what a mechanical check is after you pull off the road at the end of the day, you jack the car up on sawhorses and you have all the mech team members look at the suspension linkages, make sure there's no fatigue, make sure the car is still in good running order. So in this test, we have the car sitting on two just kind of fairly standard sawhorses, and the door was open, as you kind of saw it outside. So it was about 3 feet off the ground. Door was open. We were doing a mechanical check, and the car was just sitting there. and all of a sudden this huge gust of wind just slams into the side of the car, and you see this in like slow motion. The car goes like, it rocks a little bit and it starts tipping over. And then so the car, what happened was the door on the car acted like a sail essentially, and the car completely got knocked over off the solar harvesters and crashed into the ground. Now this was without the wheel, this was during mechanical check, so the wheels weren't on the car. The suspension components, the brake rotors, actually slammed right into the gravel, on the side of the road, and this was just devastating at the time. The brake rotors we're using are kind of like an obsolete model. We didn't actually have any more on us. We needed some more team members to bring them over from, they flew over from the States to get us these replacement rotors, but man, we just barely got out of that one before the race. We ended up having to cancel the rest of that test drive, but some really big decisions, like do we try to continue mock, this was in day 2 of our mock race. Do we continue doing that for the experience, or are we going to perform subpar, trying to stay up at 3 a.m. fixing suspension linkages, right? So fortunately, the damage wasn't too bad. It was mainly, we could switch out the brake rotors, and we decided to just kind of hold off on the rest of the test drive and get back on it the next day, and we were able to repair our car and get it all in working order. So by the time we were on the race, everything was pretty much shipshape.
Excellent. So almost exhaustion before it even began. In some ways with that drill. So just as you have to transform from a design team to a race team, some folks actually have to transform from designers to race car drivers, like Anna. Anna Olson is a sophomore in mechanical engineering. She was part of the mechanical team for Luminos and is currently the mechanical team lead for the new car. But one of the roles that you played in Australia was that of driver. And can you explain for everybody, what is the experience like of driving Luminos?
So to be blunt about it, it's completely unpleasant. I don't know if you guys have had a chance to look at the car, but you're basically sitting in a little black carbon fiber box with a not as clear windscreen as we would have liked to have. The curvature of it results in some warping, so it's not, not the crystal clear view you get out of a regular car's window. It operates pretty normally, like you would expect a car to. You have a steering wheel, brake, and accelerator. The brake pedal has 2 modes of travel. The first half is regenerative braking, and the second half is mechanical braking. So that's one thing that you sort of have to get used to. It's different from driving an average car. We have a 6-point harness. So getting in the car is sort of an ordeal of, awkwardly climbing into the box, strapping yourself in. For the race, you have your helmet, a microphone, radio with a clip, and then an earpiece to communicate with the convoy cars behind you. And then you awkwardly buckle in your harness and then realize that the shoulder strap keeps you from reaching the door to shut it. So you sort of struggle there and eventually get the door shut, or someone takes pity and comes over to help you. And then you pull out and hit the road. Because our motors are designed for efficiency and not for torque necessarily, acceleration is sort of slow. So when we were using our first iteration of our higher speed, less torque motors, testing in the Central Valley, you would crawl from a stop painfully slowly, and the motors sort of whine at this high-pitched sound. So you'd sit there at a stop sign, like lead to solar car, you're clear to proceed, or chase the solar car, you're clear to proceed, and you hit the accelerator, and then you start rolling, but then eventually you get up to speed. And at speed, it's really loud. There's no sound dampening. The tires are extremely low rolling resistance, but that results in everything in the car being extremely noisy. It's sort of a bumpy ride. We have seat cushions, but those are sort of an afterthought because the primary concern when you're designing the car is meeting the visibility requirements. Let's see.
And of course, you test in very cool environments, right? Both the testing and the race.
Yeah, there's an AC system built in. I don't know if you noticed all the fans that generate airflow for the driver. No, there's basically no air movement inside the car. And if you feel any air moving around, you're losing power somewhere. So you're obligated to report that, but also kind of, do we really have to cover up the wheels? Yeah, it's definitely unpleasant, objectively speaking, but at the same time, you're driving a solar car across Australia. That part never gets old for me.
So in addition to that, you have to endure that, but you also have to stay really focused the whole time that you're out there. What is that like?
That's probably one of the most challenging parts about driving the solar car is that so 95% of the time, or some high 90s number, it's extremely boring. Your only job is to sit there and keep the car between two straight lines on the road. Occasionally you get a call over the radio telling you to change your cruise speed, and then you set cruise control and you maintain the car in a straight line going down the road. But then the minor percentage of the time that something actually goes wrong, you have to instantly be on it and know what to do, react. You have to remain calm, but make a logical decision. And at the same time, you have to be in constant and clear communication with the chase car behind you because they're getting all the data off the car. They know what's around you. You have huge blind spots. And so they're going to be directing you in what to do. But at the same time, they don't know what's going on in the solar car. So it's a really delicate balance of handling those types of situations. And then for the other 95% of the time, when you're trying to keep the car in a straight line, your other biggest struggle is staying awake. So that was definitely the biggest challenge that all of the drivers shared. Is that so you get in and 10 minutes, you're like, this is cool, it's gonna be a great drive. I have the morning shift, it's nice and cool out right now. Thinking about, I don't know how many 100 kilometers, thousands of kilometers you have left. But then at some point it hits you that, I'm getting kind of sleepy. And so various tactics we would employ, just making loud noises. I was really glad that there was no, the radio was push to talk. So the chase car can't hear what's going on. Otherwise, I'd make faces. I'd try banging my helmet on the roll cage. And then when you get desperate, you call over to chase and ask people, or call over to the convoy and ask people to tell jokes. I think Darren and I have a couple good puns from Australia that we'd be happy to share later. Yeah, that's how it goes.
Good. So you mentioned getting that command to change your cruising speed. So that really comes from the strategy and logistics of this. So to learn a little bit more about that, we're going to turn to Max Praglin. So Max is a senior in aeronautics and astronautics, also a minor in electrical engineering, and you're staying around to do the co-term program to get an MS in EE. Is that right? Yeah. Right. And so Max has been the electrical engineer and strategist for this, and is currently the systems engineering lead for the new car. So Max, tell us a little bit about what you're looking at during the race, and break down a little bit about how the race proceeded from your perspective.
Right, so my job during the race was to look at all the data coming off the car and decide how fast to go. And when you think about how fast do I drive a solar car to get across a continent as fast as possible, the answer seems obvious. You just keep the pedal down all the time. But you'd be wrong. It turns out that the fastest way, because you have a battery pack, is not to go as fast as possible. So you might want to go a constant speed if you have a battery pack. And you might need to do something different when you have different sunlight. You might need to worry about the elevation changes. And you're making all these decisions trying not to hurt your performance, say, 5 days in the future when you don't know what the weather would be like. And my job was to look at all these factors coming in and try to end our race with 0% energy left in our battery pack. So if we can get a picture of what our state of charge looks like. The state of charge of a battery pack is very important to a solar car team. You get about 10% of the energy that it takes to finish a race inside your battery pack. And the race organizers have done a great job because this is just the right amount of energy to make things interesting. So you can walk two different paths. You can go too fast, and then at the end of the day, you're sitting there on the side of the road, your car can't drive, and all your friends are looking at you and going, why did we drive that fast? And that's a terrible feeling. Now, the other side of this is you don't go fast enough. And you're sitting in the car, and you're looking at the charge in your battery pack slowly creeping up, and you realize that everyone on the team wants to go as fast as possible. And we can talk to the drivers, but they like going really fast. So I'm just sitting there trying to make it so that when we get to the top of our battery pack, the rest of the energy that normally would go into our battery pack from the solar array doesn't get put through me, because that's what the remainder of the energy is supposed to do if I mess up. So I'm really kind of looking at this data, trying to look at very noisy data all the time and figure out exactly what the right speed to go is. And you can see from this plot over here, it's a very non-intuitive energy versus distance plot. You might think it would just be a linear ramp down, but it's not. So there's a lot of modeling we have to do, a lot of testing, and a lot of the testing that we do is trying to dial in these parameters for the car. So our race was, from a strategist perspective, perfect and exciting. We started out the race in the third position, I believe, starting. And it's really just a hectic time when you're starting from the beginning of a race. We have our driver from the first day, Ian Gerard, here. And if you ask him how the first day was, I don't know if he even remembers because it was so crazy. You have cars that are starting 30 seconds apart from Darwin, Australia, running out of a city, and you have a scout car, a lead car, a solar car, a chase car, and a trailer, all for all these teams. And they're all trying to get in the right position as you start the race. And this is really kind of a crazy start for something that's going to last 5 days. So we're battling all this, and the whole time we're trying to figure out, are we going too fast or too slow? And it turned out that we were going the exact same speed as our kind of arch rival in the United States, Michigan. And it's kind of unheard of for solar cars to go the exact same speed. So we're literally miles apart from Michigan, our arch rival, who we've never competed with on these sort of levels in the past. And we're sending cars back and forth, trying to figure out how close are we to Michigan. And we pass each other a few times. It's kind of crazy to watch another solar car pass another solar car. Not something you see every day. So this was really kind of, through the second day, just a battle of just kind of nerves. Who was able to go the right speed for them? Because at the end of the day, if you're going the wrong speed, you're going to take slower than you need to go to finish the race where you'd like to. So by the end of the second day, we're realizing that Michigan is starting to fall back from us. So we had the really unique position of, for the first time that I've heard of, outpacing another team that wanted to keep up with us. And they were just waiting for us to make a mistake, waiting for us to go too fast. They're hoping that we're trying to just lead them out there too far. But we really, we were going the right speed for us, and it worked out very well. So we kind of had another crazy day after that where we couldn't go fast enough. And because of the way our motors are designed, they're designed for a peak efficiency for the tallest hill in Australia, so we can just barely get up that steepest hill without any problems. Now this means that we can't go really fast if we're not at the top of our battery pack. So we're going in maybe 100 km/h gusts side to side, and cars are blowing off the road. There's trailers that are tipping over. It was just a crazy day, and we're just trying to go as fast as we can to catch up to the next team who is in third place at the time. And this is the Solar Team Twente from the Netherlands. And these guys are very talented, very fun people, but it was kind of a battle of the two cars that looked like whales. So we're just here in the Outback, driving as fast as we can, trying to catch up with another team who has, maybe 15 minutes on us. And that was just a whole new type of racing for us. So we had to decide, do we try to catch them and possibly risk being able to finish in the fastest possible way, or do we just race how we want to, calmly cross the finish line, and make sure we get there? So there's a great photo of us right there trying to decide on the night before the last day of the race. And we're juggling different things like, do we want to try to beat this team? Are we going to finish if we go too fast? What's the weather like tomorrow? We're talking to our Australian weatherman friend to try to figure out what the weather's like the next day. And all of these factors combined, we decide we're going to roll the dice, and we're going to go try to beat this other team because the next team back is maybe even a day behind us. So it ended up being a gamble that we lost, but we still finished in fourth place. So this is really an interesting time where we have all this data, we have all these very objective decisions to make, and for the first time we have to decide, are we going to try to beat another team and race against them, or is this really a game of numbers? It's very exciting for us.
So there's a lot of competition that goes on there, but it's not always all that competitive, right? So James Goldfield is a junior in engineering physics. He was the race team lead, and will be the race team lead, was the composites lead, right? And will be the race team lead. So you actually spent a lot of time working with some of the other teams and became quite famous for your tire changing abilities, right? So you were responsible for tires. Tell us a little bit about that.
Yeah, that's right. Well, first of all, just to back up a little bit, talk about the competitive versus camaraderie aspect. And one of the most exciting things for me to go to Australia was to go to this place where all these other solar car teams are congregating. And as one of our members said, realize that there are other crazy fools around the world who do the same thing that you do. So, even talking to other engineers here, people's eyes glaze over when you're talking about, characterizing, rolling resistance of tires or solar array encapsulation, and all of a sudden being in the same place with all these people who have put in all this time in the same endeavor that you have is actually just really great and really interesting to hear everyone's experiences and see what other people's approaches are. But yeah, so going back to the tires, we have these very fancy tires from Michelin. They're super low rolling resistance. But one quirk they have is they're very hard to seat on the rims. To actually get them in a position where they're on the rims correctly and holding air is very difficult. So we were, when we first got to Australia, we're in Adelaide, preparing for the race, and we're getting all our tires pumped up, ready to load all our spares plus the tires that are going to go on the car. And fortunately, we were working at a Volkswagen dealership. Volkswagen was kind enough to let us use one of their facilities, and they have this really interesting tool called a bead blaster. So it's basically just a steel tank about this big with a small nozzle on it. And basically what you do is you pressurize the thing up to about 160 PSI and just aim it in the general direction of the tire, and it moves in a volume of air that actually inflates the tires. So we were able to use Volkswagens when we were in the city, but going forward we needed a solution for ourselves just in case we ever needed to seat any more tires to be able to do this. So fortunately, some of our team members were actually able to find one of these devices on eBay Australia in a warehouse that actually happened to be like 10 minutes from where we're working. So we picked one of these up and we were able to seat the rest of our tires. And later on, when we were preparing for the race up in Darwin, we kind of made a lot of friends by helping seat other people's tires with this thing. So my favorite story about that is there's this team from Korea. They're a great group of guys. It's always interesting to see the kind of range of resources available to different teams. So there's some teams like us that are very blessed in terms of what resources we have at our disposal. The other teams that kind of have to make do with lower tech solutions. So this Korean team, their car was built entirely of sheet metal aluminum. It was riveted together as opposed to most cars which are composite. So a very striking looking car, looked kind of like a battleship. And anyway, as we were walking around the area where all the teams are preparing, we saw them trying to seat their tires with a bicycle pump. And even seating with an air compressor can be difficult. Actually moving enough air with a bicycle pump was basically impossible. So we're walking by, like, oh, come over, check out this thing that we have. So here's the picture of it right here. So the bead blaster is a big blue tank, and the thing is, it's really, really loud. It's basically a giant explosion of air that this thing is shooting out. So as you can see, Darren and I both have earmuffs on, so we're warning these people on the Korean team that they need to cover their ears. Unfortunately, not everyone on the team speaks great English, so one of them here you see covering his ears. The other one kind of just put his hands behind his head. So looking at this picture here, we're really glad we didn't blow his eardrums out. But fortunately, we were able to help them out and get their tires ready to roll. But it was just great to meet all these different teams from around the world, coming from different circumstances, having different experiences, and just kind of swapping notes and especially exchanging stories after the race and just meeting them.
So if you want to make friends at a Solar Car Challenge, bring a bead blaster.
Yes.
Right? But now you made other friends as well and got to celebrate Chilean Independence Day in the Outback, right?
That's right. This is actually one of the craziest things that happened to us. So this was about 2 weeks, maybe even less actually, after we got to Australia. So this is middle of nowhere in the Outback. We were basically just doing laps of this section of the Stewart Highway, which is this really desolate stretch of highway. And we're camped for the night at this tiny little, if you even want to call it a town, it's basically a gas station in the middle of the Outback. And we're camped in these little structures that they have for car camping. We have our trailer, and we're kind of cooking dinner and just kind of hunkering down for the night. And then we see, a couple of cars pull in with the trailer, and we see this, and we're like, it's kind of strange because no one else had even been staying there that night. Seeing people in that area is pretty rare. And then we see this big trailer, and we see a bunch of logos plastered on the side of their car, and I'm like, this looks like a solar car team. So it turns out this was the Anticari team from Chile, happened to be testing on the same stretch of road, happened to pull into the exact same spot as us, and they just kind of sauntered over and struck up some conversation. Fortunately, we have one member of our team who spoke Spanish, and I sort of speak really terrible Spanish. So we were able to talk to them for a while, kind of talk about their travels to Australia, how they were doing. And it happened to be, on that day, it happened to be Chilean Independence Day. So they had a couple bottles of Chilean wine. They were cooking steaks on their little barbecue pit on the campfire next to us. So we just went over, had some steak, had some wine, and it was a great night. And they kind of became good friends with us for the rest of the cycle. So whenever we'd see him up in Darwin, or occasionally during the race, or in the end in Adelaide, they're kind of our first friends in Australia, and that was really exciting. And I actually still keep in contact with quite a few of these guys. It's interesting the friendships you make just out in the middle of nowhere racing your solar car around. So.
Great. So well, let's settle one thing. There was some discussion on the solar car email earlier about whether or not you actually did make it through the Outback without stopping for gas, because you had multiple vehicles. So let's set the record straight here.
Technically
Did
true. Yes.
The solar car doesn't take any gas, so technically true, but we do have, as mentioned, a convoy vehicle. So we have a scout car that kind of sees what teams are ahead, how the conditions are, a lead car, which is right in front of the solar car to kind of warn traffic that there's a solar car coming, a chase car that gives the solar car instructions, and a trailer. Now these were all VW vehicles that were fortunately clean diesel, so we did get a good number of mileage out of them, but
So technically no gas.
technically no gas.
Only diesel in the sun.
Only diesel, but yeah. So our fleet vehicles did have to consume a little bit of diesel to get us through.
But we did not stop for gas, so the question on our poster has been answered.
All right. So Wesley, let's go back a little bit to some of the lessons that you feel that the team learned as a result of this.
It's definitely a broad number of lessons. I think some of the core lessons are definitely focused around the engineering experience. For this team to go in basically 18 months from a blank slate to developing an entire car that can race throughout the Outback forces us to learn a lot of skill sets from the engineering side to the business side. They're all very applicable for doing anything from working on Silicon Valley tech company all the way to working on a small startup. So with this team, we have a lot of pressure, both internally and also externally from our deadlines to design quickly, to find ways to get feedback from our peers and from industry experts to have design reviews. Folks in this team learn how to integrate their designs with others in very complex projects, which is really something you don't get a chance to do in a small classroom setting where, say, you have 10 weeks in a quarter to do a design project, but maybe you're just working with 2 peers. Whereas with this team, you're looking at an 18-month product life cycle. You're working with dozens of other students. You're working with corporate vendors in Silicon Valley. And really the entire experience of building this car from the ground up serves to kind of complement and supplement the experiences that students get within the classroom.
So now you found a very creative way to gain a little bit more time for the team. Can you explain how you did that?
Sure. So like I mentioned before, one of the biggest challenges for our team is the fact that we have this very short time frame for going from a blank slate to having a car that can race across the Outback. So 18 months. And in that time, our team usually allocates the summer before the race to do some extensive testing, both here in the US and in Australia. So as I mentioned before, we'll take our car out to the Central Valley and test in the farmland around there. We do a lot of testing here in the Bay Area as well too. So Foothill Expressway and Kenyatta Road are popular test grounds for us if you want to spy on us during the race time before the race. We do testing out in North Carolina where there's wind tunnels that we can get access to that are NASCAR facilities for the most part. And all this time is really precious for us. So anytime that we can get weeks, days even, can really make a big difference in terms of our team's success in Australia by having either a more reliable car when we go to the start line in Darwin, or even a faster car we can find ways to optimize over the course of the summer. So when I was leading the team, I like to create external deadlines as much as possible. That way we weren't looking at deadlines that we could just move ourselves internally. So sometimes it might be a wind tunnel reservation in North Carolina that we had to make our car get out to in time for. But for the summer, our big deadline in the sand was to get the car in a boat 7 weeks before we needed it in Australia. Usually our team will ocean ship our car because that's the most cost-effective way to get the vehicle from the US to Australia. Even then, it's a $16,000 expense usually, though usually air shipping would cost our team around $50,000. So this last year, I tried to make a big effort to try to find a corporate sponsor that could support our team with air shipping. So I tried UPS and DHL and FedEx and anywhere where I could find Stanford alumni or anyone with a Stanford connection at these companies. I tried to make inroads, but I had very little success for months on end. And we had kind of given up hope as a team, myself included, until a couple of weeks before the date that the car was supposed to be in a box going on a boat to Australia, where I got some inroads with Virgin Australia and Virgin Atlantic, and made some progress with negotiating sponsorship. And then a couple of days before we were supposed to ship, I got the confirmation. And I don't like to play all my cards when I'm trying to get the team to do things, so I didn't necessarily tell the team that we had a sponsorship to get the car
And now
to Australia.
the team was out sweating in the Central Valley at the time, right?
I mean, I was in deep with the team as well, and we were doing our final test drive that we thought would be in the Central Valley. And at the end of the test drive, I sent the team an email that I thought would be great news and would make everyone all happy and excited. Do you have that picture maybe? So I sent them just this one picture of our brand new sponsor, which was Virgin Group. And the news was we would have an extra month, yay, of testing that we could do. So instead of the car being on a boat for 7 weeks, we would only have the car out of our hands for about 36 hours between dropping off the car in LA and then the car showing up in Melbourne, being cleared through customs. But I don't know. What did you guys think
All right,
about?
so Max, yeah, you're out there testing the car, and this wonderful news comes through. What was that like?
I don't know that I can find the right words to describe just the totally different directions that took me. In one sense, I was just hoping for more time to get all these parameters right for our car, get all our models done. And at the other side, here I am thinking, all right, this is the last test drive. I've put off doctor's appointments. I haven't seen friends. I'll start to sleep again. And we get these emails, and it's like, Wesley has done an incredible thing. I can't say how important it was to the team. And I think a lot of how well our car performed was because we had the chance to do one extra test drive, test out a couple new ideas. So it's just these sort of things that, they seem like a great idea, but at heart, we are all students. We all put a lot on the line for this. It was just a very multi-directional, emotional place.
I remember sitting right about here as all of you came back from that trip, and it was sort of amazing, to hear all of the reactions. And I couldn't quite figure out, was everybody going to give Wesley a big hug or strangle him? It was sort of a little ambiguous there. Well, I want to do a little bit of free association here, jumping in on some of the native creatures in the Outback. Let's start with kangaroos.
Oh, yeah. Okay. Kangaroos. So Australia does have a lot of kangaroos. And they're actually primarily nocturnal creatures, so they'll kind of get attracted to this road surface at night when the road is warm and the weather's cooled down a bit. And the problem with this is that there's a big shipping lane straight through Australia, which is what we drive on. So road trains, these 3 or 4 trailer long semi-truck configurations what they have adopted is, they'll call them roo guards, where it's just a steel grate in front of the truck. They won't stop because they can't stop, and they'll just run these kangaroos down. And it happens, there's roadkill on the road, and we have to navigate that the next day. So we caught wind of this during test driving. You'll sometimes have to avoid a dead kangaroo on the road. But what's even more interesting is how this factors into racing. So this is how I learned that there was a thing called the shovel car, where some of the top teams, because they have to leave, they kind of pretty much lead the whole convoy, is they'll have a car with a shovel in the beginning of their team that drives it for them, and they'll have to shovel the roadkill out of the road for their solar car to pass as less of a safety hazard. Now, that's kind of interesting in itself, but what's even more funny is some of the less scrupulous teams, their shovel car will shovel the kangaroo out of the road, the solar car will pass, and they'll put the kangaroo back on the road. So that's our little kangaroo story for Australia.
Emu.
So I think this was one of the most exciting moments I had in the solar car. So we were on a test drive in South Australia, driving back and forth across the same stretch of road. The usual solar car, hold your lane, solar car, set your cruise speed. Solar car, brake, there's an emu on the road. So there were indeed these large ostrich-like flightless birds. You see them running alongside the road. And so I, focused on the road, the usual 4-hour driving shift. And then I hear some chatter on the radio about guys, lead to convoy, there are birds alongside the road. Like, okay, birds, crows, we've seen them before. Occasionally they're roadkill, but you're usually clear to drive over them. And then all of a sudden very urgent calls from the chase car, like, solar car, start braking. And the thing is, you don't want to instantly slam on the brakes because that can cause your tires to lock, and then that's one of the most reliable ways to get a flat tire. But at the same time, you don't want to hit one of these birds because they will probably mess up your car substantially. And yeah, so that's my experience with the emus in the solar car, but I think you guys have interesting perspectives to add from the rest of the group.
So I was actually driving the chase car at this point, so I heard this whole radio conversation. So this was Harry Johnson, our old electoral lead, who I think is here, was on the lead radio, and of course, which is completely okay. He wasn't completely familiar with, Australian wildlife, so he saw birds. So he reported that there were birds on the road, and that was completely true. Yeah, so again, I wasn't really on the lookout either. Then one emu actually ran between the solar car and the chase car, and at this point we're probably about 30 feet apart or so. So a car actually ran between us. Yeah, so that was pretty harrowing. So that kind of became a running joke. Gave Harry a lot of, good-natured ribbing for it. So, we'd say things like, as the drive progressed, we'd see these big lizards that live in the Outback, and they often sun themselves on the road. So whenever we'd go by, Harry would call out, "Oh, guys, watch out! There's a lizard on the road," and everyone's like, "Oh yeah, it's probably a 20-foot crocodile."
How about spiders?
Oh boy.
That's another challenge so one of the challenges, I guess, of the race is that you're, at the end of the day, you just pull over wherever you are and camp alongside the road. And there generally aren't any restroom facilities for most of the 3,000 kilometers of Outback. So you just kind of have to wander out into the bushes. And very early on during one of our test drives, Rachel, our code lead and one of our backup drivers, was pointed out this trick to me. She's like, "Hey, Anna, want to see something cool? Take your headlamp and hold it up right by your eye, right here, and then look out over the ground." And I saw, it was like as if those like reflective stripes on the safety vest we wore is as if you took one of those stripes and shredded it up into a bunch of tiny little pieces and sprinkled it all over the ground. So I saw all these like reflective little specks on the ground. She's like, "You know what those are? Those are spider eyes." Every single set of those is a pair of spider eyes looking back at you. And all of a sudden, going to the bathroom in the Outback becomes a lot more challenging.
Sort of becomes another optimization problem, right? How deep into the spiders and how far away from camp, one of these more things to balance. All right, finally, road trains.
Wait, do you have the picture of the house?
So Australians have this habit of moving very strange things all over the country. So sometimes you'll see just a big train of sheep. And these are like a semi-trailer in the US, but 3 or 4 of them long. So these are just monstrous things. They can't stop. When you're on the radio with these truckers, you can't understand them. I've been told they're speaking English. So sometimes you'll see something ridiculous like a house on the road. So you'll get a call over the radio that there's a house approaching. You're like, okay, I probably heard that wrong. But no, you literally have to get off the road because there is a full-sized house coming down both lanes of the highway. I don't know what's with Australians.
So we have this great video of course, our entire convoy pulled off the side of the road with this house going through, and we actually took this video, set it to the song, "Our House in the Middle of the Street." Put it on our Twitter. So. And
then Darren and I had this idea. So we were responsible for Greg, our engineering lead, called tweeting twits. He was getting familiar with the social media terms, and so he's very excited about our new twit team that was responsible for all our social media coverage during the race. So every morning he'd be like, "Anna, we have an hour to brainstorm our morning twit." And so this house was a prime opportunity. Jamie, when we made the call for the house on the radio, Jamie sang that song over the radio, and then Darren got the video on his phone, and we're like, "Oh, we should set the video to that song, and then post it as a tweet." And then our caption for the tweet was, "Pulled over to let these homies pass. How's this possible?" Unfortunately, the video, the song, and the computer with the internet never made it all together. But maybe we'll have a hashtag TBT, throwback to Australia, tweet someday.
Awesome. Well, do we have any questions from the audience? Do we have a mic for Adele? Is there a mic for Riley?
I just want to congratulate you on the massive amount of engineering accomplishment, but I haven't heard a word about the human factors and the bioengineering, and have any of you taken Dr. DeMent's class on sleep, and do you understand that for peak performance, you actually have to get enough sleep?
That's definitely a big factor during the race. I think Wesley can speak to that, but as a driver, I know that it was definitely important and very helpful to get a full 8 hours before every day of driving. And during the race, can't speak for the rest of the cycle working on the solar car, but during the race, did get a full 8 hours every night to drive the solar car.
Yeah, fortunately, so my roommate just before the race was one of the head TAs for Dr. DeMent's class. So I'd heard all the stories about the importance of sleep, and I was fully well versed on the needs for people to get good 8 hours of sleep. So this year we actually had sleep schedules, and we had organized plans for who would be driving which cars when. That way people always had a 4-hour rest break in between any kind of drive shift, and no one, for the most part, drove more than 4 hours. I guess the one downside, though, is that some folks unfortunately ended up with shifts where they're back-to-back driving, I don't know, the trailer, one of the less glamorous vehicles. So the big Touareg, or the Touareg that we had was pretty comfortable, I would say, in Australia. Right? Big leather seats and a nice navigation system. Good stereo.
So this is interesting. When I was here, we didn't have a lab like this. So what we did is we test drove in Lake Lagunita, and we had Lagunita Seca. I don't know if you heard about that, but that goes way back. What was interesting, though, is I noticed that a couple of you were pointing about going off the road this way, but you're the driver, right? If you go off the road this way, you're going the wrong way. You're driving on the left-hand side of the road, and I just wonder how long it took you to get used to the left-hand side of the road.
So fortunately, we had a lot of time, like 6 weeks in Australia, I think, we had a month basically before the actual start of the race. And so, yeah, the first time I drove on the left was with one of our Volkswagen convoy vehicles in Melbourne, I think. So by the time that I was driving the solar car, I was very well versed in driving on the left and pulling off on the correct side of the road. There's a sort of a funny running joke about, or something we noticed in the rules was that, so you have an observer traveling with you for the course of the race, and they make sure that your battery is locked up in a box at the end of the night. They have a GPS tracker so that the race officials can follow where all the teams are. And they'll report any things that you do wrong to make the appropriate time penalty. Usually it doesn't happen, but one of the things is if you're driving on the right side of the road instead of the left side, that's a safety violation of sorts, and so they'll deduct a time penalty for that. But the thing is, they're not obligated to tell you that you're driving on the wrong side of the road. So the observer can just let the team, in the morning they get up, they pack their convoy, the car gets on the road. A team could very well start off on the right side of the road, like the wrong side in Australia, but the right side of the road, and just drive for as many hours until they encountered traffic or something and realized that they were on the wrong side without the observer saying a word, but the entire time, marking them down for it. I don't know if that actually happens, but that was one situation we joked about.
One other funny thing about that actually is, again, I got used to driving on the left pretty quickly. You kind of reorient your instincts pretty quickly. But the only time I've really driven a manual transmission for any amount of time was actually in Australia, because we had a manual vehicle and I figured I'd learn. But I can't drive a manual here because the stick's on the other side.
I think we had some questions in the back, if we can get them. Could you wait until the microphone comes so we can record you for posterity?
Can you shed a little light on what the design formula you've been given as a participant? So what do they construct the car and the components and the weights and the various parameters that they give you?
So the race is, well, the main design is to finish as fast as possible, and this ends up being just shy of 40 hours, between 30 and 40 hours for the top teams. There's certain big design parameters, like you get 6 square meters of silicon solar panels. So that kind of determines, as you can see on our car out, how big the car is going to be, because you have to fit those 6 square meters on top. Other big design constraints are, you may have noticed out of those 3 cars out there, there's 2 with 3 wheels. So that was the big shift for this cycle, was that every once in a while to try to make the cars more consumer-like or more realistic, so the driver will seat up a little bit more. And in this case, the races will now be all 4-wheeled vehicles, so you'll go from 3-wheeled for aerodynamics to 4-wheeled for a more practical car.
What about wheel dimensions and components? Is there a series of parts that you have to use, or is it all up to the different teams?
That's pretty much open-ended. Our steering rack is kind of, you're free to design any part you want. There's a thing called scrutineering before the race, where engineers and kind of race officials will examine the cars and make sure they're safe and apply to regulations. But in our case, for example, like the brakes on the car are adapted from actually bike rotors. So it's a 370-pound car. It doesn't need as much braking force as like a full mechanical brake of a production car. So there's some places where you adapt design to kind of optimize for just your really lightweight or your solar car application.
So I've got a more serious question for you guys. Full disclosure, I did solar car in the past, since graduated. And one of the things I remember realizing while I was on the team was at some point you realize that what you're working on is a little bit more than a problem set. And if you screw up on the problem set, then that's the problem set. But if you screw up on solar car, someone could really get hurt, right? And it's something that every team member has to come to grips with. So this is mainly for Wesley and Max up there. I'm wondering when did you realize that what you were working on here was actually really important, and how did that realization kind of affect the way you did engineering, and if it still affects you today, how does it continue to do so?
Sure, I think for myself, the moment I realized that solar car racing was really important the way that Nathan described was the first time I heard about a death happening in solar car racing. So there's been two, fatalities in solar car racing. One was from heat stroke in the Outback. The other was a head-on collision in Toronto a number of years ago with a team that crossed a double yellow line and hit a small minivan. So for this team, we do place a large focus on safety and especially testing, because we realize that members on our team that are driving the cars are our friends, they're our classmates, and to lose someone, even if they're just injured and not actually killed, would be devastating for our team. So this cycle, every single cycle, our team puts a large focus on design reviews, like I mentioned before. The test miles we put out on the car are both to exercise the vehicle itself, but also to train the team so that the drivers know what to do to get out and evade, or to evade a potentially dangerous situation. We do drives on test tracks even to give our drivers a chance to do kind of controlled but really dynamic evasive maneuvers. Even our operations crew and the race crew itself, while we're in Australia, we do a lot of these drills where, for example, we practice tire changes over and over again, so that if we do a tire change during the race, we don't botch the tire change and put the driver at risk with a improperly installed tire during the race. And altogether, we do everything we can to reduce the risks, but every day we realize that people's lives are on the lines in a way that's not really present in a problem set or even a lab experiment here on campus.
The first time I probably experienced this was when Zenith, one of the cars out there, was being tested, and I was listening to one of the software engineers talk about the rear-wheel drive system and how you can steer it. And that was the first time that I realized that there's things like software that can have physical implications. So if you use the wrong data type for what angle you want to set your rear wheel at, you could have that roll over by just one count, and that could set it to the opposite side, flipping a car. So there's some really important things that you have to take care of and make sure you're diligent, and that's why it's important for us to always bring in people who have done this before. They've seen all the mistakes. And that was one of the biggest takeaways I've had from Solar Car is just that there's always someone who's done this before and understands it better than you do, and there's no shame in asking them to look at it.
And that's something that translates to the race itself, right, Jamie, in terms of the checks that you would do every single night?
Yeah, that's right. Yeah, one thing we did after each day of racing and after each day of testing was, we'd put the car up on sawhorses. You saw the picture earlier, and we'd check basically every single bolt on the car, make sure nothing came loose, make sure all the putty holding the bolts on was still intact, make sure nothing was cracked, make sure all the suspension linkages were all still intact. So, yeah, again, that's something that means a lot to us. And it was kind of strange doing that every day because, of course, we do the checks every day, everything was fine. And it's easy to kind of convince yourself that, oh, this is kind of pointless, we could skip one, do we really have to check every single bolt every single day? But yeah, when you really think that some of your best friends are climbing in that car and driving on a road, on a public road, then, it all kind of comes together and makes a lot more sense.
Final quick hits here before we wrap up, and then hopefully you'll be able to stay around for people who want to chat and see the car a little bit. Just really quickly for each one of you, what has this experience meant?
Me personally, I don't think I would have been in any of the situations otherwise. So I've gotten to work on a project outside of class that just goes way beyond what you learn in the classroom. I've gotten to talk with our partners in industry. I've gotten to talk with professors, gotten to talk with other people who do this crazy thing in the other parts of the world. Gotten to be in the middle of Australia. And it's just a huge part of my Stanford experience, as well as just a very formative thing for a young engineer.
Absolutely phenomenal. So I joined after the bulk of Luminos had been designed, helped out with sort of the tail end of some small design projects, and then was really around for the summer characterizing the car and then taking it to Australia to race. And just even in that, wasn't involved with the initial design of the car at all, but learned so much just by osmosis. And that's sort of how our team operates. Is just you hang around and you just absorb knowledge, and then eventually. You bring the car back from Australia, and then you sit down with the team or Skype in from abroad, as was my case, and start planning for the next cycle. And you realize that, wow, it's at some point between Australia and where we are now, the wand has been passed down, and it's our turn to build a solar car. And so it's crazy to think that a year from now we'll be constructing the next car, and in 2 years we'll have raced it across Australia again. And so that's what's really incredible about this experience to me, is that you join as a wide-eyed undergrad with no concept of anything that you think would be useful to the car at all, and then eventually at some point in the cycle realize I know how I can answer someone's question about how this thing works. I can put this part together. I can reassemble and do a mech check of the suspension. And then all of a sudden you're tasked with building the next car. And while I have, absolutely, I could not alone, no one alone could build a solar car, and I'm absolutely terrified at the prospect of it, I'm also completely stoked and so excited to be working with this next team on this next project. And so yeah, that's what's really phenomenal about it, and means a lot to me.
So yeah, I feel the same way as Anna and Max in a lot of ways. I think the biggest thing that was influential for me in the Stanford Solar Car Project was getting the opportunity to explore a totally new industry and even a new career path. So I think Professor Gerdes mentioned that I was an economics major at Stanford. My freshman and sophomore year, I was focusing on career paths where I was going to look at something like corporate finance or management consulting. But through the team, because the team is so open to anyone that comes onto the project, and the people on the team, the upperclassmen, the alumni, the professors that support our team, are willing to teach and train anyone regardless of your background. I was able to learn the skills I needed to, for example, help design the manufacturing process for the array on Zenith, and coordinate a lot of the testing and logistics for the project as well. And then eventually, for the Luminos cycle, I learned enough just working hands-on on the team that I was able to lead the project in building the new car for 2013. And now, even though I have an economics degree and I wasn't actually an engineering major at Stanford and I only took a handful of engineering classes, I was still able to find a way to get into a career where I'm doing automotive work in an engineering space. And really the team was a place that I could kind of make an orthogonal change from the career path that I was on previously.
Cool. Yeah, a lot of what's been said before, just really a lot of growth for me. I remember coming in as a freshman, just really amazed that a bunch of college students could build a car and would you want to get in that car, to being to actually have gone on the race, seen that car do well, and just realizing that you've been a part of this. It's just a great feeling. I was involved in a lot of the manufacturing for the previous car, but now the challenges ahead are designing the next one. And what I'm really appreciative of is just the great network of alums that stick around. It's really just kind of learning from, somebody's faced this problem before, somebody's gotten stuck exactly where you have before, and being able to ask them. Now, I'm, Anna and I meet regularly with the mech team lead from 2 cycles ago. We just chat, have lunch, and just really get wisdom that trickles down. So kind of, one of the greatest things is just having that network, that family that you build through Solar Car, and learning from people that have been, where you are before.
Yeah, I think the biggest thing I've learned is just how incredibly awesome an opportunity this is for me to have, and how really it is, has become the most important thing I will do at Stanford. I joined about a year ago, and I was really amazed to see a lot of the older members just completely throwing everything they had at this project, often at the expense of sleep, of social life, of academics. And often I didn't quite understand it for a while, and I didn't quite dive into it as much as I should. But certainly after going to Australia and just seeing more about what this field has to offer, I know that through this program I've learned more about engineering, certainly than I have in any of my classes. And that not everything you do in school is necessarily about grades. It's about kind of optimizing your experience to learn what you want to learn. And this is just such a spectacular project that way, talking about learning from osmosis of just the amount of collective knowledge that our members and alumni have, and the potential that has to educate me as an engineer is just absolutely phenomenal. And it's just really taught me that this is something that is really, really important, and something that I'm going to throw everything I have at for the next car.
Well, thanks to all of you for being willing to come here and talk about your experience tonight. Thanks for all of you for joining us and for the great questions. And I'd just like to ask you to join me to bid congratulations and thanks to the team one last time.
I'm excited, our team's excited. We're here at the start of the 2013 Bridgestone World Solar Challenge. Over the next couple of days, our team will be driving around 2,000 miles across the Australian Outback. We think we have a very robust vehicle that's also efficient. So we're looking for a top 5 finish, hopefully, in this year's race.
So today is race day. It's a little surreal to be here. You kind of start to reflect a little bit on 18 months of everything. I mean, the sleepless nights, just the agony and the ecstasy of it all.
Good and good? Yep, down. Okay.
We're recruiting for Google X specifically, and we're looking for a lot of mechanical engineers and electrical engineers.
So Solar Car to me was extremely formative. It was a very important time to figure out how to actually build real hardware, to take what I've learned in class and actually turn it into real physical, tangible things that have to work on a hard deadline.
I guess I should say that Solar Car is about 95% of the reason why I got my job.
I'll be driving the first shift, which is exciting. We're ready to go racing.
Next, the Stanford guys, Stanford from Colorado in the US.
We've been looking at the weather for the next 4 to 5 days. If we don't go fast enough, we could run into some bad weather near Adelaide. So the name of the game is going to be driving fast and just reserving only enough energy to get into Port Augusta, which is the last stop before Adelaide.
Finally being in the race was definitely exciting, although that sort of wore off after the first hour, and then it was just a struggle to keep wiping the sweat off your face, and the temperature instantly rises and you start baking like it's an oven in there, which it is. It's just a giant carbon oven.
So we wake up before the sunrise and we set up the array stand, picking a position where we're going to get the most sun that we can. We push it upright and we point directly at the sun. And then what people do is we adjust the angle of it back as the sun goes up, still keeping it pointed directly at the sun.
We're 4th now currently, and ahead of Michigan, but we passed Michigan twice. That's exciting.
So our team's very excited. We've been gaining very quickly on the Twente Solar Car team from the Netherlands. At the start of the day, we were around 40 minutes behind them. And now it's the early evening, late afternoon. We've finished our day of racing, and Twente is just 6 minutes ahead of our team.
I think everyone is starting to get a bit tired of camping in the Outback. I haven't taken a shower since the morning of the race, which would be 4 mornings ago.
So we're at the last control stop right now. The Solar Team Twente is in 3rd place, and we're about 10 to 15 minutes behind them. It's really going to be a race to Adelaide. Don't know if we have enough sun to get there, Don't know if they do. It's a high stress time right now.
Awesome. Like, we're the first team to finish from Stanford in forever, and we did it properly. We didn't stop, we didn't break down.
Feeling relieved. 4th place, best finish ever, I think, for Stanford, so couldn't be much happier.
So for myself and a lot of other people that are on the solar car team, we have a strong interest in both the clean tech side of the project, but also the automotive aspect. A lot of the members on our team go on to work in the automotive industry. Hopefully for the next cycle, we'll have another group of students that are just as dedicated to the project with equal or more success. And hopefully for the next generation of the team, they can vie for a top 3 finish in the 2015 race.
You.